talking about the field activity that we have undergoes with participants. We've been sampling the soils at different depths to teach them how it is important to recognize the different stratification that can occur in the soils in the unsaturated zone during the agricultural field activity, I mean before sowing and after the harvest. This was undertaken by taking multi-level samplers, soils, and also using suction lysimeters and groundwater multi-level samplers to track the fate of inorganic nitrogen from the topsoil to the target, that is actually the unconfined aquifer, the groundwater, or the surface water. They learn how to samples in the correct manner, and overall they learn using multi-level samplers how to sampling and to have a clear conceptual model. What is exactly a matrix to sample? Not only the soil matrix, but also the soil water that can be sampled using suction lysimeters. So we have seen together different aspects of the same problem about nitrogen movement through the unsaturated zone. In addition, we have seen that data loggers can be really helpful to understand what is the transient behavior of our water percolation in agricultural fields. So they've seen installed different kind of data loggers and the limits and the accuracy of each instrumentation that can give additional information to each partner how the water is behaving in the unsaturated zone and what is the time frame that it needs to reach the target, surface water through runoff or groundwater through percolation. Finally, we went to another field site equipped this time with a multi-level sampler within the unconfined aquifer to track the fate of inorganic nitrogen species percolating from the topsoil. In this case, we parameterized the aquifer properties, and participants have learned how it's difficult and challenging to parameterize aquifer properties and how they are heterogeneous, even in very small field sites. So they understand the level and the accuracy of each different technique, pumping test and slag test, and they possibly bring at home a new skill, new knowledge on how much they have to trust their data, their own data, or how to implement new data that can really improve their conceptual model. Going deeper, nothing happened. It means that the rain reached the topsoil, increased the water content in the topsoil that can store a huge amount of water because it can, have a porosity of 45-46%, this kind of soil. So if it's dry, then it can absorb a huge amount of water, and you have no percolation events. So it means that the groundwater, in fact, is going down. Another important aspect of the course was that the participant can bring at home a different level of analytical technique that can be employed to measure and quantify concentration of inorganic nitrogen species in soil water and groundwater. This was achieved using ion selective electrodes that are really simple instrumentation but really cheap. And also we visit the biology department labs to see more expensive techniques like the UV-Vis spectrometry to analyze, or out-analyzers to analyze nitrate, nitrite and ammonium. Clearly the costs are different, but also the accuracy of the analysis were really different. And also we have seen ion chromatography to have a clear snapshot of all the ions and cations dissolved in groundwater or in soil water to get an overall picture of what is going on in the pore solution. And clearly this is another step advance, and it's much more cost, but gives to the participants and as an analytical technique much more information than the others. So all the participants have the opportunities to understand different levels of accuracy and also different kind of instrumentation that can be used to monitoring the fate and transport of nitrogen species in surface and groundwater. In addition to different analytical techniques, we have also seen different laboratory experiments to solve parameters that cannot be directly measured or hardly measured in the field, like ammonia volatilization or denitrification. These have been measured literally in batch experiments in the biology department that have been constructed during these years of the project, and the participants have had the opportunity to see and also discuss about this experimental setup. So they also have learned how to build up their own batch experiment and to measure, for example, the ammonia volatilization or the denitrification potential or actual of their soil. These are really important parameters that must be estimated. Finally, we open a discussion about the analytical techniques, different analytical methods and techniques that each partner have been adopted so far to have an overall picture of the heterogeneities of soil sampling and analysis, analytical technique so far used, and each partner have learned the difficulties that can arise going sampling and how have they treat their own data already acquired in their database to improve their conceptual models of each country. In addition, as a final remark, I would say that with all the other colleagues that participate at the laboratory experience, we believe that each participant have grown up their experience, peculiarly in the analytical techniques used and in the field sampling, and we bring all together a new level, an upgrading level for the overall project that could be possibly encourage future exchange or possibility to develop experimental setups together.
We took a lot of knowledge here, and GIS methodology is something which is new for me personally and also for my country.
I think such events are very helpful and can improve the development of GIS technologies in our countries.
We will use these maps to be applied in the region of Istria to change maybe agricultural policy regarding water and nitrogen management.
I think that such courses are very important to exchange the knowledge that university have gathered for a lot of years, though the knowledge we do not have in Moldova.
Mama, I'm on TV!